So, good day everyone. To begin with number one, let us first read the question. So, the wheel is rotating about an axis that is in the z direction. The angular velocity WZ is negative 6.00 rad per second at t is equal to 0. Then increases linearly with time and is positive 4.00 rad s at time equals to 7.00 seconds. We have taken counterclockwise rotation to be positive. So A is the angular velocity during this time interval positive or negative? Letter B is during what time interval is the speed of the wheel increasing or decreasing? Then letter C, what is the angular displacement of the wheel at T? So we know that our z-axis is perpendicular to the plane xy, and the rotation of the wheel is about the z-axis, positive for counterclockwise from the positive x-axis and negative for clockwise from positive x-axis. So the angular velocity wz is increases linearly with time. So our given time in seconds. Then our w sub z is our angular velocity, rad per second in our points, given points. So 0, 6.00 is actually negative. So our point 2 was to 7.00, comma 4.00. So to find the linear equation of angular velocity in terms of time, we write the formula of our formula is wz is equals to mtv. Then since angular velocity increases linearly, then find the slope between the given points. So first we need to find the slope. So our slope is equal m is equals to 4.00 minus negative 6.00 to positive over 7.00 minus 0. So this is equals to 10 rad per 7 seconds squared. So this is actually our answer, but we need to solve for our wz. wz is equals to 10 over 7t minus 6.00. Then our answer for letter A is az is equals to dwz dt is equals to 10 rad over 7 seconds squared. So the angular acceleration is positive during the given time interval. So note that is equal to the slope because there is a linear relationship between the angular velocity in the line. So this is our answer for the letter A. So let's proceed now to the letter B. So letter B. So the question is, during what time interval is the speed of the wheel increasing? So note that between the points A and C, so A and C, WZ is negative, WZ is negative, and AZ, or our angular acceleration, is equals to positive. So then WZ is increasing at the time interval, so it's increasing on the time interval. So our time interval is 0 t. So the wheel is turning clockwise with the WZ equals to 6 s at time t0, but it rotates slower and slower, so slower and slower until wz is equals to 0 at time is equals to 42 seconds. So between points C and B, between points C and B for 4.20 t 7.00, we wz is positive, so wz is positive, so wz is positive, and and AC is positive also, so then WSA is increasing. So the wheel now rotates counterclockwise faster and faster from D 0 at T is equals to 4.25 seconds until WSA is equals to 4.0 at T is equals to. So our answer to conclude that, so decreasing axis decreasing for 0 less than equal T less than 4.2 and increasing for 4.2 T 7.00. So in letter C, WZ is equals to d theta dt, or d theta is equals to WZ cross multiply dt. So WZ is an instantaneous angular velocity. Assume that theta is equals to 0, theta is equals to 0, and t is equals to 0, and integrate to find the angular displacement. So we know that integrate d theta is equals to d 0 10 7 6.00 dt. So theta equals to 10 14 t squared minus 6.00 t. So the angular displacement at t is equals to 7.00 seconds. So theta 7.00 is equals to 10 14 7.00 squared minus 6.00 10.00 is equals to negative 7.00. So this is our answer for the letter C. To begin with number 2, first, we should read the problem. Three forces are applied to a wheel of radius of 0.350 meter are shown in the figure. One force is perpendicular to the wheel, one is tangent to it, and the wheel makes a 40.0 degrees angle with the radius. Question: what is the net torque on the wheel due to their three forces for an axis perpendicular to the wheel and passing through its center? So after analyzing the problem, first let's list the given numbers. So our given right here is the radius. So our radius is 0.350 meter. So next is our force. So it is said in the problem that our first force are perpendicular to the rim, which is this one, the 11.9 newtons. So our first force is to 11.9 newton. Then our second is tangent to it, so tangent to it 2 is right here on the 8.50 Newton. Then our third force is the wheel makes a 40 degrees angle, so here 14.6 Newton, and then our angle is equals to 40.0 degrees. So the problem asks for the torque, so our solution is what we want to find is the net torque. So first we need to find the torque of each given forces. So the formula for the torque is T is equals to R, which is the radius, then F, which is the force, then sine theta. So to begin with, let us proceed to the first force. So T1, let's say it is T1. So our radius is just substitute the values 0.350 meter, then substitute the our force is equals to 11.9 Newton sine theta. I'm sorry, so our theta right here, since it is said that it is perpendicular to the beam, so perpendicular equals to right angle, so 90 is equals to our theta is equals to 90 degrees. So we can solve right now. 0.350 meter multiplied by 11.9 Newton sine 90 degrees is equals to 4.165 Newton meter. So this is our torque 1, torque sub 1. Then for our second torque is equals to the same value for the radius. Then our force is equals to 8.15 Newton sine, so for our still 90 degrees, we can see it in the figure. So this equals to 2.975 or 2.98 or 2.98 Newton meter. T sub 2. So for our third torque, so same approach, so just substitute the values for the radius 0.350 meter multiply, so our force is 14.6 Newton sine, so our angle right now is 40.0 degrees. It is given in the problem already. So this one 0.350 meter multiplied by 14.6 Newton sine 40.0 is equals to 3.28 Newton meter. So we are at the last part for solving the net torque. So solving for our net torque, I am giving this formula the sum of these three torques. So T1 plus T2 plus T3. Okay, so our T net or net torque is equals to, so our T1 is 4.165 Newton point meter plus or T2 2.98 Newton point meter plus 3.28 Newton point meter, so equals to 10 6.425 Newton point meter. So this is our answer. So to begin with number three, first let's read the question. Find the magnitude of the angular momentum of the second hand on a clock brought on axis to the center of the clock face. The clock hand has a length of 15.0 cm and a mass of 6.00 gram. Take the hand be a slender rod rotating with constant angular velocity about 1 meter. So here, we are asked to determine the magnitude of the angular momentum to the second hand of a dot about an axis through the center of the clock face. So let's list the given values. So our given is we have our length, the length of the duck hunt, so 15.0 centimeter. Then our mass is equals to 6.00 grams. So here's a formula for our angular angular momentum. So formula for angular momentum is capital letter L is equals to I. I is the moment of inertia, and the small letter W is the angular velocity. So this is the angular momentum, the moment of inertia, the moment of inertia, and the angular velocity. So what we need to do first is to convert the minutes from centimeter to meter or grams to kilogram, because the units for um, angular momentum is in kilogram meter square per second. So we need to convert the length, the 15.0 centimeter, multiplied by 1 meter is equals to 100 centimeters. So this equals to 0.150 meter. So for our mass, 6.00 grams multiplied by, we know that 1 kilogram is equals to 1000 grams. Cancel. So this equals to 6.00 times 10 raised to negative 3 kilograms. So now we have what we need. Second, we need to find for the angular velocity. So it said that the second hand makes 1 revolution. So the second hand makes 1 revolution in 1 minute. 1 minute or 1 revolution in 60 seconds. So and angular velocity is equals to 2 pi rad 60 seconds. So it is also equals to 0.1047 rad for seconds. So we're going to substitute these values into our angular velocity later. So now let's solve for the moment of inertia for a slender rod with the axis about one end. So moment of inertia formula. This is the formula. Moment of inertia is equals to 1/3 ml squared We have our mass and our length squared. So just substitute the values. 1/3 multiplied by our mass 6.00 times 10 raised to negative 3 kilogram multiplied by the length squared, so 0.150 meter squared. So this equals to 4.50 times 10 raised to negative 5 kilogram point per squared. So now we have what we need. We have our angular velocity, then our moment of inertia. So what we'll do right now is substitute those values to our formula um, for our angular momentum. So angular momentum is equals to value of moment of inertia 4.50 times 10 raised to negative 5 kilogram point meter squared multiplied by our angular velocity, which is 0.1047 rad per second. So our angular momentum is equals to 4.7 times 10 raised to negative 6 kilogram per meter squared per second. So that is the answer. Number 3.